Hello students, welcome back. Let's go to section 3, Data Description 1, Graphical Description. As the name suggests, there will be Data Description 2, but that's going to be covered next week in Lesson 2. Now, how do we describe data? There are many ways, and one way to do that is through a pie chart. And here's an example. Let's consider a hypothetical class, and in that class, 1 student earned an A, 6 students earned a B, 10 students earned C, and 4 students earned a D, and 2 students failed out of total 23. And this pie chart is associated to that data. So A, 1 out of 23, and then the center angle here is 1/23 of that's 360 degrees. B is 6 out of 23, so center angle here for B, this color here, the orange color, is 6/23 of 360 degrees, and so on. C is most populous in 10/23 out of 360 degrees, and so on. That's one way to represent the data through the pie chart. Now, if you use technology, you can easily draw like that. But if you have to do it by paper and pencil method, then getting the center angle may be a bit of an issue there. So you have to get the relative frequency, for example, 10/23, and then times 360 degrees to get this angle. Good luck about that. Now, another way is to get the bar chart. We have A, B, C, D, and F, and height represents the frequency, how many students failed. Or you can use relative frequency as well. It's going to be the same deal, as a matter of fact. Here I use the frequency. As you can see, the label 10 goes to 10 people like this. 6 goes to 6 people like that. But if I take relative frequency, you're going to see exactly the same picture. Only these numbers will change because it's a scaling issue. Multiply everything by 1/23. It's just a scaling. So you're going to get exactly the same picture. Now, as for horizontal, we have these nominal variables, A, B, C, D, and F. Excuse me, did I say nominal? Sorry, it's ordinal variable. Ordinal. You see, A is better than B, B is better than C, C is better than D, and so on. So this is ordinal. Not quantitative, it's qualitative, yes, but it's ordinal, not nominal. Okay, that was bar chart, and that's easiest to draw, and even with paper and pencil, with ruler, anybody can easily draw bar chart. Next, Pareto Diagram, and this one actually is good for nominal variables. It's not really good for ordinal variables, but here we go anyway. Pareto diagram is a combination of the line graph and the bar graphs put together, but there is a rule. The most populous one first, the next, and then the next, and then the next, and then the next. So all these bars goes down. Okay? So if you have nominal variable, then changing the order is perfectly fine. If you have an ordinal variable, that can be a bit problematic here, because A is better than B, but why is A all the way to the right hand side? What's the order of the C, B, D, F, A? If you just look at the alphabets only, it doesn't make much sense. So Pareto diagram is not really good for this particular example, but everybody can just force it anyway, and here's the one I just forced it in. If those were not the grades, but just anything else, then this would have been working just fine. For example, if this just A, B, C, D, F, those are not the grades, but name of the favorite basketball team, for example, Team A, Team B, Team C, Team D, Team F of a certain class, and then turn out most students' favorite Team C, for example, kind of like that. In that case, well, those names do not really have any kind of order, so you can rearrange like this freely. And that's what Pareto diagram is all about. Now let's go to this line graph. Line graphs gives me the cumulative frequency. So first we have, let's see, relative frequency is 0.4 something, let's say 10 out of 23. So 0.4347, okay, that's the height. And then cumulative, so I have to add the next one. So next is 6 out of 23. 6 out of 23. And then 0.69 something there. And then cumulative, so I have to add up the next. Now 4 out of 23 and 0.869, that's going to be this one. And add one more, eventually adding everything, I'm going to get to 1. So the bars go down and then the line goes up. That's Pareto diagram. How useful is it? For this course, I'm afraid not very much, but still, there you go anyway. Okay, we did pie chart, bar chart, Pareto. This one is a little bit more important, and it's called a dot plot. And let's suppose we have a data set like this. Again, we have hypothetical class. One student earned 33, 58, 64, 67, 67, 69, 72, and so on. Those are scores. Now 33 is right here. A dot here, do you see where my mouse is at? And then that is right on 33. Next, another dot at 58, right here, 58. 50 is here, 60 is there, and 58 right here. Next dot is 64, so we need dot at 64. 60 is here, 70 is there, 64 is right here. Now, we have 67 and another 67. We need 2 dots at 67. 67 here, we need 2 dots, so we have 2 dots. Make sense? And then 69. Now we have all these in 70s. Okay, 72, 73, 73. 72, I have this dot, and 73, I have 2 dots. And 75, at 77, I have 4 dots. Indeed, there are 4 dots. Do you see? And then 2 dots at 79, and so on. So in this diagram, even if I don't know any of these, I can still retrieve a good deal of data just by looking at this dot plot. I can precisely find out whether this is 58 because 50 is there, 60 is there, and then there are 1, 2, 3, so there are 5 intervals there. So this is 58. I can clearly see it precisely. And here, these 4 go to 77. I can clearly see that. 76, 78, right in between. 77, there are 4 of them. So you can retrieve everything. Now let's go back to other charts. I can see how many students got A, how many students got B, and so on, but what are their scores? I cannot see from here. Same goes to the bar chart, and same goes to the Pareto diagram. But from the dot plot, I can retrieve this data precisely. Also, I can see the concentration. I have some concentration right here in the middle. And then I can see outlier. This is really strange. One student doing really badly, maybe missed a second exam or something. So I can see the distribution of the scores here just by looking at the picture. So dot plot is useful in that regard, and I frequently write dot plot problems in homeworks and sometimes in exam as well. As for pie chart, bar chart, and Pareto diagram, as homeworks, yes, okay, but for exams or anything more significant, never. Because information I can get from these are really limited, so there's not much mathematics in there. In dot plots, yes, we do. Okay, the next topic, stem and leaf display or stem and leaf chart. This too is important, and I frequently write this in the exam and homeworks. This is standard stem and leaf display. Let me expand the font so that you can see this part better. We have stem part and leaf part, and stem part is 10 digits, tens here. As this diagram said, stem units is 10th digit. And leaf digit is of course ones. So if we have 33, then we have 3, 3. Now if you have 58, we have 5, 8. Okay? 10th digit is 5, 1 digit is 8, so 5, 8 like this. Now we have these 4 numbers in 60s. 64, 67, another 67 and 69. And look at the stem and leaf display. Stem has 6, so 60 something. And we have 4 numbers here. 4, 7, 7, 9. So we have 64, 67, another 67, and 69. So I can easily get these numbers from the stem and leaf display. And vice versa. From here, I can easily make this, and vice versa. 70s, we have 72, 73, another 73, 75, many 77s and 79. Look at here, and there are 10 students at 70 something earning grade C in this hypothetical class, and their score is 72, 73, another 73, 75, and 4 77s and 2 79s. You can clearly see them all from the stem and leaf display. You can go back and forth easily. And then 80 is similar, and then highest in 94. Also, I can see the concentration. You see, you have this big hump at 70 and coming down. So we can see the distribution of scores as well. You could see the distribution of scores from this dot plot. Okay, I'd better make this a little bit smaller. Okay, I can see it from the dot plot. As you can see, you have this hump. Similar thing is going on here. You can see this kind of hump. So I'd like to emphasize the last two, dot plot and stem and leaf display. The others are far less important compared with these two. This is where I'm going to stop for now. We talked about 2 important graphical presentations, and the others were not that important.